All right, today we're going to talk about comparing and ordering fractions, and there's several different ways in which to do so. We'd like to have as much reason or justification or explanation as possible to back up our thinking when we're trying to compare and order fractions. So if we just start off by taking a couple fractions like maybe 1/4, and let's compare 1/4 with something like, how about 2/3? In this case, I would hope that most of us already understand that 2/3 is going to be the greater fraction. I also hope that we understand how the inequality symbol faces. It wants to point at the little guy, kind of wants to gobble up or eat that bigger guy up, you know. So how did I know that so quickly, and how would you know that so quickly? We used our basic benchmark or landmark fraction of a half and a whole. I know that 1 out of 4 is less than a half, and I know that 2 out of 3 is more than a half. And that is enough reason or explanation to decide upon my inequality. Another fraction pair that might work for that one would be something like 4/5 compared to something like 3/7. Again, sevenths, these are not very fun and familiar fractions. The seventh isn't a very common unit that we know and deal with very often, but we do know that 3 out of 7 is less than half, and that 4 out of 5 is more than half. So our benchmark or landmark would be a good explanation or justification for this inequality symbol being correct. Okay? Another way we can explain or justify our inequality symbol might be just from our basic understanding of fractional parts. For instance, if I was comparing 1/5 with 1/4, I know that fifths are smaller than fourths. If I take a pizza and cut it into 5 slices, and take that same pizza and cut it into 4 slices, I know that these slices are going to be smaller. So that would just be my general understanding of fractional pieces, my number sense. Number sense, or understanding fractional parts. That would also work in a case like this. I have 1 piece and 1 piece, and I know that fifths are smaller than fourths. Same could be said when I have 4 out of 5 being more than 3 out of 4. 4 out of 5 is only missing 1 piece to make a whole pizza, and 3 out of 4 is only missing 1 piece to make that whole pizza. I know that fifths are smaller pieces than fourths. Therefore, there's more of the pizza left over in 4/5. Okay, so my number sense or understanding of fractional parts would be a good explanation for this comparison. Okay, sometimes, especially in our class, we've talked a lot about fractions and decimals and percents and how they're all the same thing. So if you know for sure your fractions and decimals and percents, I could know for sure that 5/8 is less than 2/3. Now, I gotta really be up on my fraction and decimal and percent equivalents to know that this is 66 2/3%, and this is 62.5%. Or I could write it as a decimal as 0.6 with a line over it, and 0.625, or 62.5. Again, we could do that with a lot of these if we have done a good job studying and remembering our percent and decimal equivalents. For example, I could take 1/5 and compare it to 1/4. Again, this would be a case where we would just take our understanding, our understanding of fractional pieces, but I could also use my decimal and percent equivalents. I know that 1/4 is 25 hundredths, and I know 1/5 is only 20, or 20% compared to 25%. Okay? A lot of us are seeing these equivalents every time we see these very well-known benchmark fractions. You're starting to see these equivalents, which is great to see. Okay? The biggest way and the most for sure important way that we're going to be focusing on moving forward in our unit is going to be looking at a common denominator. Okay? And so when we have a common denominator, it means that our pieces are going to be the same size. These right here, these would be pretty tough to do. Okay, sevenths and twelfths. I'm not going to start with them because sevenths and twelfths, their least common denominator is going to be the product of those two numbers. It's going to be 84. It's going to take us a while to find that out. So let's start with a more basic example, like 2/3 compared to 5/12. We need to find that common denominator of 3 and 12. And sometimes it already is there for us. It's 12. I'm going to change 2/3 into something in twelfths. Ask myself, how do I get from 3 to 12? Times 4. Whatever I do the bottom, I got to do the top. It's going to be 8/12. And now I have 8/12 compared to 5/12. It's very easy to tell that 8 is more than 5. So moving forward, our common denominator is going to be the real #1 way we're going to be able to prove a fraction is greater than, less than, or equal to another fraction. And most importantly, it's going to be important for adding and subtracting fractions, because we cannot add and subtract unless our pieces are all the same size. Let's do one more example of common denominator with a different fraction. A couple of fractions that are really kind of close to each other. We might not know. Okay, how about 3/7 compared to 2/5? Okay, I can't use this knowledge because they're both just under half. So that doesn't really help me understand which one's bigger. So that one's out. I can't really use this knowledge because I don't know much about sevenths. I do know that sevenths are smaller than fifths, but if it was 1/7 compared to 1/5, then I could use this information. That doesn't really help me here either. I gotta talk about my common denominator. So I have two numbers, both of which are prime, 7 and 5. To find their common denominator, we gotta multiply them together. I could find their common denominator by listing out the multiples. 5, 10, 15, 20, 25, 30, 35, 40. Okay, try 7, 7, 14, 21, 28, 35, and there's our peanut. Mr. Peanut, as we like to talk about in class, can help us find our common denominator. Okay, fantastic. So our common denominator is 35 times 7 over here, 14. It's different over here though, times 5 and times 5 to get 15. Look how close those were. 15 35ths compared to 14 35ths. This guy's just one tiny little 35th bigger, which is very difficult to prove without using the common denominator. So please make sure to be looking for that common peanut, and when in doubt, list them out.